There are certain situations in statistics where there's a predetermined margin of error and we're asked to find the sample size with a given percent confident that we wish to be. Those sorts of problems are called sample size problems, and we can have them when we're working with the population parameter, that's the proportion, whether we have a pre-estimate for p-hat or don't have a pre-estimate for p-hat, as well as for the population mean, and also for the standard deviation and the variance. Now, determining what the question is focusing on and which parameter they're talking about helps us determine which formula we should use or if we should reference a table. I've written over to the side 3 different formulas that we have for sample size and a question that asks for a sample size for a specific setting with a parameter of and also with the level of confidence. So let's go through the video and look at how you determine which of those 3 formulas to use, and then also how to carry out and finish out the problem. So here it says, find the minimum number to be included in the sample. So find the minimum number to be included in the sample, find how many need to be in the sample, how many need to, all those sorts of wordings in a question kind of set you off to say, hey, this is a sample size question, so I need to focus on either these formulas or on referring to a table. Next up, it's to be 88% confident that the sample proportion, p-hat, is within 0.05 of the population proportion. So this is a sample size question with a proportion. Now, in looking at these 3 formulas, the top 2 are sample size questions for a proportion, and the third one down is a sample size formula for the population mean. And we have a proportion, so it's one of these top 2. The determination between which of these 2 it is whether you have a preliminary estimate for your p-hat or not. And in here it said nothing about any initial values or any values that we could reference for a p-hat approximation. So it's not going to be the one that involves the p-hat notation. We don't have any numbers to put in that. The second one down is the sample size formula if you are doing this process for a population proportion sample size idea and you don't have a preliminary estimate for the proportion. So these top 2 are proportion. The top 1 is if you have a preliminary estimate for p-hat with a proportion. The next one is if you don't have a preliminary estimate for the proportion. And then this bottom one is the only one you use for when you're looking at sample size for the population mean. So our setting needs this formula. Now, what we need to find to do this is just the z sub alpha over 2 and the e. Now remember, z sub alpha over 2 is the z-score so that you have that little bit of the alpha is the leftover area in the tails, and divide by 2 is how much is in one of the tails. And then we've got our level of confidence here of our 88%. So to find z sub alpha over 2, we think of our normal distribution. That 0.88 is in the middle. The distribution is symmetric. The entire area cut between the curve and the horizontal line is 1. So we're going to take 1 and subtract the 0.88 to get 0.12. That's your alpha. That's the amount that's shared between the 2 tails. And then we divide that alpha by 2. So 0.12 divided by 2 is 0.06. And that's the amount of area that's in each tail. Now, to get the z-score, when we know the area, we need to use the inverse norm. Or we can look up information up on a table. This video is going to center on using the inverse norm from like a TI-83, TI-84 calculator. So, inverse norm is the operation we're going to do to find the z-score if we have the area. To access that on your calculator, you're going to push the second button. and then you're going to push the button that says VARS on the button and DISTR on the face of the calculator. That's to get to the distributions. It's right next to the clear key. Now when you do that, you're going to have several different options. That's where your normal CDF is, your inverse norm, inverse T, binomial CDF, binomial PDF, all of those different options. We want the inverse norm. And then the way that they engineered this when they programmed the calculator is the input, when it says like area, if you have the menu driven or if it's inverse norm with an open parenthesis, the area they're talking about to get that z sub alpha over 2 is all of the entire area left of that cutoff. Now I can get that in one of two ways. One way is to think the entire area is 1, and this is the entire area except for that tail. So 1 minus 0.06 is 0.94. The other way to think of it is say, well, if it's area all the way left, I'd have to add 0.88 and 0.06, which is still 0.94. So I have 0.94, the mean of the z-scores is 0, the standard deviation of the z-scores is 1, and when you go through that calculation, that's 1.555. So that's my z sub alpha over 2. So then to do the rest of the calculation for n, remember it's this formula, it's 0.25 times my z sub alpha over 2, the 1.555, divide by e. Now in these problems of sample size, when they tell you the margin of error, they're either going to say that your sample proportion p hat is within so much, or plus or minus so much, or with a margin of error or so much. So that number that follows the word within or any of those other phrasings, that's your E. So you're going to take 1.555, divide by 0.04 in parentheses and square it, and then multiply by the 0.25, and you get n is equal to 241.80. But I can't give that as an answer because it's a sample size. It's how many you're going to sample. So you need to have a whole number answer for these, and you always round up. So 241.80, we round up to 242. So that is your sample size that you need to meet those requirements.